Good evening. Welcome to the problem solving session for week 5. I hope I'm audible. Uh, Please respond if you can see my screen.
Good evening. Yes, ma'am.
Good
I
evening.
can
You can
see.
see it, right? Okay,
Yes.
so I'll just wait for a couple of more minutes and then we'll get started with today's session. I hope that's okay.
Okay.
Okay. Okay, so I'll just start. Okay, so I'll be discussing week 5 problems today. Before going into that, do you have any doubts with respect to week 4 or the other weeks? If there is anything, please let me know. Please feel free. Okay, if not, then I am going to start today's session. So, uh, once again, I'll introduce myself. I'm Shreya and I'm the TA for this course. So, we'll discuss about we'll discuss problems related to concepts that were discussed during week 5 lectures. So, briefly, we touched upon ANOVA and the types of ANOVA that we have, like whether it's a one-way ANOVA or a two-way ANOVA. So, what do you mean by a one-way ANOVA? Anybody? So, what actually is ANOVA? This is analysis of variance. So, what is the difference between one-way and two-way ANOVA? Anybody? Please feel free. Like, give me one example of an ANOVA of a one-way ANOVA and a two-way ANOVA? No one? Okay, so if I give you an example, let's say I have uh, some sort of sales, okay, as a data point, and that sales could depend on the type of packaging I'm using. Okay, so if I see that if it is in a red packet, it is getting it's getting higher number of sales than if it is in blue or green packaging. So then in order to find out if the color or the type of packaging is having any effect on the sales, or rather a differential effect on the sales, in those kind of situation we use ANOVA models, where we are modeling some sort of a response Y based on these categories. So these categories are nothing but levels of the explanatory variable. Okay, and why this is called analysis of variance? Because we are doing this analysis by partitioning the sum of squares into an explainable part and an unexplainable part, or we are partitioning the entire sum of squares, the total sum of the square deviation from the mean, into two parts. So this is SST will be divided into sum of squares between plus sum of squares within. Between and within what? Between and within levels of the variable. If we say this is the variable x, okay, now this is an example of one-way ANOVA. So if similarly we have two factors, so let's say this is factor A, type of packaging. Also, apart from type of packaging, if it depends or if it is expected to depend on some factor B, which also has like level 1, level 2 and so on and so forth, then that design would come into a two-way ANOVA. Is this clear, the basic thing? Okay, and what we mean by an ANCOVA model is that we have a response variable y. There are some predictors which are continuous variables. So let's say the sales is dependent on price and plus some sort type of packaging. So then this term becomes the covariate in the model, and thus we have an ANCOVA analysis where we'll have some factors involved with some levels of some factor which can be categorized into different levels, and also a covariate or a continuous type of variable. So these kind of study designs are usually tackled by ANCOVA. Is it clear?
Yes, ma'am.
Okay, so I'll just briefly recap what was said. So in one-way ANOVA, as we were saying, we have one qualitative factors or a grouping variable with 3 or more levels and one continuous dependent variable. So as I was saying, for this sales example, this is the continuous variable which we are modeling as a dependent variable. And as an independent variable, what we are having this qualitative variable type of packaging, and the levels are red, blue and green. So here we have 3 levels. We could have 2 or more levels, right? And here the objective is to evaluate the difference among the means of 3 or more groups. So what I'm from this thing, the hypothesis for this example would be, is there any differential effect of the type of packaging on the sales figures that we have? If not, then well and good, and if there's an effect, then what? So that question we are going to explore further. Now, the most important thing before applying a one-way ANOVA are the assumptions of the model. So we have to be extremely careful when we are working with real life data. We have to look at the assumptions that are there, and we have to see that these assumptions are satisfied. So the first assumption is we should have independent random samples for the purpose of comparison. The second one is the populations from which the random sample is being drawn should be normally distributed. And the third and important criteria is that the population variances across each of the categories are equal. Okay. So as illustrated with this diagram, here we see for each of the curves the spread is more or less equal. So this homogeneity criteria is satisfied. These all look like coming from a normally distributed curve, and they are independent samples from group 1, group 2 and group 3. So then in such scenarios we can go ahead and apply the one-way ANOVA and do our analysis. So first we'll try to look at what is the hypothesis. So the null hypothesis will be that all treatment means, or all means of the group means rather, are equal. And the alternate hypothesis is that not all population means are the same. So if we have a model like Yij equal to mu plus alpha I plus epsilon ij, then alpha I denotes the effect of being in group I, and epsilon ij is the random error corresponding to the jth participant from ith group. Okay, so Yij means, let's say if it is sales, then sales for jth person in ith group. Let's say I1 is red, I2 is blue, and so on and so forth. Okay, so what we have to do, we have to estimate all mu and the error variances, and the total, as I was saying in ANOVA, the concept is the total sum of squares, sum of SST, can be split up into the dispersion between the factors or the group mean samples and the sum of square within groups, that is the dispersion that exists among the data values within a particular factor level or group. Okay, so how will we go about the data? The first thing we have to do is that we have to estimate the grand population mean with the grand sample mean. So combining all groups together, we must have some sort of population mean that will be estimated by the combined sample mean. For each of the individual population means, we will use their corresponding sample means. The effect for group I, that will be replaced by Yi, the sample mean for the ith group minus the grand mean, and the population errors would be the actual observed minus whatever was the group mean of the ith group. So this is the total deviation from the grand mean that can be written as the effect, as a sum of the effect of our group I plus the sample residual, that is the deviation from each of the individual group means. So then what, from the previous equation, what we are going to do, we are going to square these up and then we are going to sum it over I and j. So after doing that, we land up at this sort of an equation where this is nothing but the total sum of squares and this is the between group sum of squares and this term represents the within group sum of squares. This equation we'll call it as an ANOVA identity, and if we divide the sum of squares divided by their corresponding degrees of freedom, then we are going to end up at the mean square, mean sum of squares, mean square between and mean square within. So for a one-way ANOVA where k is the number of levels, the MSB, the between sum of squares, will have a degrees of freedom k minus 1, and for the within sum of squares it will have a df of capital N minus k, where capital N is the total number of observations entirely, okay, not with respect to any group. So then once we have this MSB and MSW, we are going to calculate the ratio MSB by MSW and then compare it with the F critical, which is nothing but F distribution with k minus 1 n minus k degrees of freedom. And if we find that the observed F value is greater than this F critical value, then we are going to reject null. And what was null? That M1 is M2 equal to whatever we had, MK. And then we reject null and conclude that at least what was the alternate? That at least one population mean is differing from the other, okay, not all population means are the same. So this is basically the logic behind one-way ANOVA. Now the thing is, if we reject the F test, I mean by using this F test, if we reject H naught, then we are accepting what we are failing to reject, I would say. We are failing to reject that all group means are equal. So then we have to find out that which are unequal. So in order to test for that, we do pairwise comparisons, and here we'll do students t test, as we have seen, for because pairwise we did last time, you remember, 2 sample mean test or 1 sample mean test. So those kind of tests we are going to do, basically students t test, and to determine if the pairwise categories, if they are equal or not. So if if then we are going to test out mu1 equals to mu2 versus mu1 not equal to mu2, again mu1 equal to mu3 versus mu1 not equal to mu3, and so on and so forth. So after this is rejected, the original hypothesis that not all group means are equal, then we have to go for pairwise comparisons. And we can also calculate the confidence interval, which is given by this squared bracket that you have, where T is the T score based on the chosen confidence level, that is T critical based on the degrees of freedom, and S will be the square root of the mean squared within. Okay. So this is how we should go about a one-way ANOVA. So before proceeding further, I would like to do 1-2 sums related to one-way ANOVA. Okay. So this is question number 1. So I'll give you some time to read the question and then we'll start. Okay, I hope you have read the question. So, a soap manufacturer sells identical soap in 3 different wrappings at the same price. Wrappings are differentiated by 3 different colors. The sales data for 5 months are given in table 1. This is exactly like the example that I gave you. We assume that data are normally distributed with equal variance. So, this is one assumption that whenever you are going to do the analysis in real time or in the real world, you should check if the assumptions hold. So, here we are assuming that the assumptions hold and we are proceeding with the problem. So, on the basis of the data, we have been asked to test at 5% level of significance whether the mean soap sale for each wrapping is equal. So, the hypothesis is that let us consider mu I to be the mean sale for the ith wrapping. So, here we have I going from 1, 2 and 3. Okay. So, our H naught is mu 1 equal to mu 2 equal to mu 3 versus H1 is not H naught, that is not all wrapping have the same mean. Okay. So, then how are we going to proceed with this? So, what is the total number of observations here? We have 3 groups and 5 observations in each group. So, here we have 15. Okay. So, n is 15. This is fine. So, now we are going to compute what are the sum of squares between and sum of squares within. Okay. So, before that I will take this to a new page. Alright. So, if we can see here, this is the total sum of squares between and sum of squares within that we need. So, if I write down the formula one more time over here, so sum of squares, one second, my pen is not working, it seems. Just a minute. really sorry. It's not working, it seems. Okay, so I'll try to use my this thing. So why is this not coming? Okay, so let it be. Okay, so summation over I and over j y I j minus y not bar whole square. This is my sum of squares total. So how you are going to calculate this one? This will be equal to finally this will be equal to, so first we'll calculate y not bar. So how we are going to get this? This will be 87 plus 83 plus 79 plus 81 plus 80 plus 78 plus 81 plus 79 plus 82 plus 80 plus 90 plus 91 plus 84 plus 82 plus 88 divided by 15. So what we'll do, we'll get the total mean irrespective of whichever group these variables fall in. Okay, so once we have that, this will be equal to, can you please calculate what this will come out to? $83. Okay, so this is coming out to be 83. So now we have to find out this total sum of squares. So then double summation ij yij minus y not bar whole square will be nothing but 87 minus 83 whole square plus 83 minus 83 whole square plus 79 minus 83 whole square plus 81 minus 83 whole square plus 80 minus 83 whole square plus 78 minus 83 whole square plus 81 minus 83 whole square plus 79 minus 83 whole square plus 82 minus 83 whole square plus 80 minus 83 whole square plus 90 minus 83 whole square plus 91 minus 83 whole square plus 84 minus 83 whole square as 82 minus 83 whole square, and finally 88 minus 83 whole square. So if you calculate, how much will this come to?
The sum is 240.
How much?
240.
Yes, we are getting it to be 240. Correct. Okay, now we have to find out this was the total sum of squares. Now we have to find out either of SSB or SSW. That will only work. Why? Because we know of this identity SST equal to SSB plus SSW. So we'll find out how to calculate SSB. Okay. So here SSB is like yi naught minus y naught naught whole square. So we have to find out yi naught first. We'll insert a slide. Let me just copy this. Okay. So we'll keep these informations whatever we have with us. So y naught naught bar was 83, SST was 240. Alright, so now SSB is what? This is yi naught bar minus y naught naught bar whole square. So this can be written as summation I, since this is independent of j, and this could go till the number of individuals in each group. Here we can write ni yi naught bar minus y naught naught bar whole square. So here in this case ni is equal to 5 for all I equal to 1, 2, 3. So this is common. So then SSB becomes summation over 5 into yi naught bar minus y naught bar whole square. So y1 naught bar is nothing but 87 plus 83 plus the group means plus 81 plus 80 by 5. How much is it?
82.
Okay, this is 82. Similarly, y2 naught bar is 78 plus 81 plus 79 plus 82 plus 80 by 5. How much is this?
80. 18.
How much?
80. 80.
80. Okay, 1 second. Okay, and what about y3 naught bar? This will be 90 plus 91 plus 84 plus 82 plus 88 by 5.
87.
Okay, then SSB equals to 5 into 82 minus y naught naught bar was 83. So 82 minus 83 whole square plus 5 into 80 minus 83 whole square plus 5 into 87 minus 83 whole square. So how much is it coming to?
130.
5 into 1 square plus 3 square plus 4 square. It's 5 into 1 plus 9 plus 16, 26. This is how much?
130.
130. So we have SST 240 and SSB 130. So we are going to now construct the ANOVA table. So here comes the ANOVA table. So first column will be sources of variation, sum of squares, the degrees of freedom, mean squared, and F. So these are the 5 columns of an ANOVA table. So source of variation between groups, the sum of square is coming out to be 130. Within groups, we don't know yet, and the total, it came out to be something around 240, right? Okay, so now we have this, that keeps SST equal to SSB plus SSE. So within groups, source of variation will be 240 minus 130. So it will be 110. If we have to verify this thing also with the formula, if you remember, SSE is nothing but this formula, Yij minus Yi naught bar. So how, if we have to calculate how we are going to do it, this is double summation Yi naught bar, Yij, sorry, this is Yij minus Yi naught bar whole square, sum over Ij. So for this one, for this example, this will be 87. So here, if I have to find SSE, then it will be 87 minus 82 whole square plus 83 minus 82 whole square plus 79 minus 82 whole square plus 81 minus 82 whole square plus 80 minus 82 whole square. Then again plus, when we are considering this one, we will subtract it from group mean 80. 78 minus 80 whole square, 81 minus 80 whole square, and so on and so forth. Okay, You understood? If we have to calculate it raw, then we have to just subtract each of the observations in each group from their group mean and then square it up. Or we can use this simplified formula as well. So now, when we are talking about between groups deviation, then the degrees of freedom, if you can remember, it was if there are k levels or k groups, then the degrees of freedom was k minus 1. So here we have how many groups? We have 3 groups, 3 wrapping groups. So degrees of freedom will be k minus 1, or rather 3 minus 1, that is 2. For total, the degrees of freedom will be n minus 1, and n here is 15. So we will have 15 minus 1, that is 14. And degrees of freedom is also additive. So if 2 is here, 14 is here, we will have another 2 as within group, another 12, another 12 as within group degrees of freedom. Is it okay? Now we have to find the mean square. So for mean square, what we are going to do, we are going to divide this by the degrees of freedom. So here we have 65, here we will have 12. How much will this come out to? This will be 9.167. Okay. So now the F test is MSB by MSW. So this will be 65 divided by 9.167, and this one will come out as 7.09. I hope you are getting this. Now,
Yes,
if nothing is mentioned, we have to compare this one with an F critical value, like the upper alpha point. We have to find out the F upper alpha point 0.05 of an F distribution. I mean such point x such that this area is 0.05. And what is the degrees of freedom of that F distribution? This be k minus 1 n minus k, or in other words, it should be from F to 12. Okay, so now from the ANOVA table, we see that our F observed from data is 7.09, and F critical, that is F2 12 0.05, this value has already been provided. This is how much? 3.88. So our rejection rule was if F observed greater than F critical or F2 12 0.05, then we are going to reject H naught. So here we see that F observed 7.09 is greater than 3.88, which is equal to F critical. Hence, we reject H naught and conclude that the mean soap sale is different for each wrapping. This is our conclusion. Is it okay? Any doubt?
Uh,
Yes.
I have
Yes.
so like in normally it mentioned like wrapping 1 and 2, 3. Like from the 5 observation in each wrapping, we can see that the mean from each wrapping is different.
Hmm.
So does that imply that uh, the significance like mu1 is not equal to mu2 is not equal to mu3?
Okay, so this when you're talking about real life application, this if you spot differences between wrapping in your sample, that will give you an indication of whether you should go for testing or not. Okay, but depending on this formal level of significance, based on that you should take a call whether they are significantly coming out different or not, because there can be biases in selecting these samples, and so in such a way that the means come up really close to each other or very different from each other. But what depends is that with what confidence we want to say. That confidence level is specified by the alpha parameter or 0.05 parameter that we are trying to establish over here. Okay, so
Okay.
with that
Uh,
we can formally state that we think that this is significantly different, and we are this 95% confident that the means are different.
okay.
Okay.
So these wrapping 1 and 2 and 3 are like samples from the whole wrappings.
Exactly. These are
Okay.
samples from the population. We, based on this sample, we are trying to infer about the population. Now, it may happen due to due to sampling biases or something, these may come out to be very different. But what is actually happening in the population level, that we don't know, that is unknown. So we need some sort of probability or confidence to state these facts that maybe in the population level these are different.
Okay, ma'am.
Is it
Thank
clear?
you.
Okay,
Yes, ma'am.
thank you. Okay, so any other question? Okay, then if not, then I'll move on to the second question. Here again we have a similar sort of problems. I just wanted to highlight if we have different number of data points for each of the groups that we have. I think somebody is unmuted. If you are not participating, can you please mute yourself? Okay, I have muted you. Alright, so we'll move on to the next one. So, data on scores on a national level college entrance examination for randomly selected students from each of the 4 highest ranked schools is given below. So, from here we have to construct a one-way ANOVA table and find out if they are equally good or not, if these 4 schools are equally good or not. So, one way to do is to construct a one-way ANOVA table. So, similarly, first we will find out the group means if possible. So, what is the group mean of this one? First we will write down the formulas: yij minus y naught naught bar whole square. S is between would be summation yij minus yi naught whole square. Sorry, this is SS within. SS between would be yi naught bar minus y naught naught bar whole square, and SS within is double summation yij minus yi naught bar whole square. Okay, so we'll just write it down. So here if I have to write, let's say these are y naught bars. So what is the mean of this one? Can you please find out?
Uh, 625.5.
Okay, this is 625.5. What about the next one? Are you sure this is 625.5? This should be 628.
Yes, ma'am. So
Yeah. So this one, for this one,
can I
yeah, see,
478.8.
478.8.
8.
Okay, what about the next one?
518.8.
Okay, and what about this one?
It is 397.
Okay, so we have y I not bar. So what will be y not bar then? 4 into 628 plus 5 into 478.8 plus 5 into 518.8 plus 6 into 397 divided by how many total number of observations are there? What is the n over here? 1 2 3 4 1 2 3 4 5 4 5 9 5 14 and 6 20 divided by 20. So how much will this come out?
509.1.
This is 5. I think there's some mistake here. Can you recheck? This should come out to be something around 494. This should be something around 494.1. Can you please check if you are getting this? You are getting it? Is it done?
Yes, ma'am. I got
So
494.1.
494.1. Okay.
Yes.
So once we have this and this, then we have to find out SS between. So SS between is nothing but summation, as I said, ni, because this j is, there's no j term over here, so this will come out y naught bar minus y naught bar whole square. So this will be, so here we have 4 into yi naught bar, that is 628 minus 494.1, plus here we have 5 observations, so 5 into 478.8 minus 494.1 plus 5 into 518.8 minus 494.1 plus 6 into 397 minus 494.1. How much are you getting this?
Ma'am, is it 0?
0? No, 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 it should not be 0. Where are you getting 0? Kindly recheck. It's very unlikely, because you see variance of 0, if you are saying, it means it's actually a constant value. sorry, here we have to use squares. We have to square it up, because summation yi naught minus y naught naught bar whole square. I forgot to put the squares. Thank you for pointing this out. Now calculate.
Actually, I got very big number.
Yeah, it's fine. You see how much you got?
13,25,082.
Okay, 1 second. I'll just. How much did you get?
13,25,082.
I think there's a shift in the decimal.
Oh,
132,508.2.
yeah.
This is
Yes.
what I got.
Yes.
Okay. Okay, so we have the sorry, 1,32,508.2. This is sum of squares between. Now we have to calculate sum of squares within. So for this, what we have to do? This is nothing but 528 minus 628 whole square plus 586 minus 628 whole square. So plus 680 minus 628 whole square plus 718 minus 628 whole square. Then again for the next column, this will be 514 minus 478.8 whole square, and so on and so forth. Okay. So you understood, right, how you have to calculate from each of the individual groups. You have to subtract the group mean and then you have to square it up and add it. So that's one way to go about this problem. If suppose you have been given a slide like this, like you have been given the data like this, and you have information, let's say, so this figure we got SSB, how much it's coming, we know, we'll keep it at the side. Now suppose you are given the sample S1 square, S2 square, S3 square and S4 square, the sample variances of each of the groups. Let's say it's been provided to you. For example, here let's say S1 square is let's say 7522.667. S2 square is 4540.700. S3 square is 80 4618.7 and S4 square is 4614.4. Okay, let's say this is given to you. Then from this information, how you are going to find out sum of squares within? So this is nothing but n1 minus 1 into s1 square plus n2 minus 1 into s2 square plus n3 minus 1 into s3 square plus n4 minus 1 into s4 square. Because see, for each, if you divide this into I equal to 1 to 4, let's say if you separate it, this will be y 1j minus y 1 naught whole square. So that is nothing but n minus 1, because this is sample variance. So if you remember, for sample variance we had the formula as summation y minus yj minus y bar whole square. So here if we see the formula, double summation yij minus yi naught bar, I equal to 1 to 4, j equal to 1 to ni, let's say. So it will be summation I equal to 1 to ni y1j minus y1 naught bar whole square plus summation I equal to 1 to ni y2j minus y2 naught bar whole square plus summation I equal to 1 to ni y3j minus y3 naught bar whole square plus summation I equal to 1 to ni y4j minus y4 naught square. So this is nothing but each of the individual group figures minus the group mean whole square. So if you draw parallel here, this will be n1 minus 1 into s1 square, because if we divide this by n1, so this will be n1 to n1, 1 to n2, 1 to n3 and 1 to n4. So if we divide by n1 minus 1, then we would have s1 square. Okay. So this is an alternative way, if you are given the sample variances, how you should calculate. Okay. So now let's suppose you have this information only, then how you are going to calculate? Let's say n1 is how much? 4, n2 is 5, n3 is 5 and n4 is 6. So S1 square, it has been given as 7522.67. S2 square is given as 4540.7. S3 square is 8018.7 and S4 square is 4614.4. So now calculate n1 minus 1 s1 square, this will be SSW, plus n2 minus 1 s2 square plus n3 minus 1 s3 square plus n4 minus 1 s4 square. So how much are you getting this? So this will be 3 into 7522.67 plus 4 into 4540.7 plus 4 into 8018.7 plus 5 into 4614.4. Anybody got the result? Yes.
95,877.61.
Okay. Fine. So this is your SSW. SSB we had gotten it. This was, if you remember, 132,508.2. So now we are going to construct the ANOVA table. So here we'll have sources of variation. Okay. So we'll have between groups and within groups and total. Sum of squares, degrees of freedom, mean squared, F. So this one between group came out as 132,508.2. This one was 95. How much was it? 877.61. So then total sum of squares is adding these two up. So how much are we getting? Is it okay?
Yes.
228,385.81. Now we'll talk about the degrees of freedom. So how many groups were there here? 1, 2, 3, 4. So then degrees of freedom would be 4 minus 1, that is 3. And here within group how many were there? It should be n minus k. So n was how much? N was 20 minus 3. Sorry, k is not 3, k is 4. So it will be 16. And the total degrees of freedom will be capital N minus 1, that is 19, or adding these two up. So then the mean square will be 132,508.2 divided by 3, and this one will also be 95877.61 divided by 16. How much is it?
Mean square for between groups 44,169.4.
Okay. And this one?
It is 5,992.35.
Okay. So then the F statistic will be how much? So F will be MSB by MSW. So F observed in this case will be 44169.4 by 5992.35. How much is it coming to?
7.37.
7.37. Okay, and we have to compare against it against F critical. So what will be the degrees of freedom of the critical F? What will be the degrees of freedom? It will be 316. So 316, 0.05 we have got to find out. So do you have the F table with you?
Mm, no, ma'am.
Okay, so then I have to find out the degrees of freedom. Uh, what are they? 316, right? Okay, 1 second. One second. Okay, so F316. So from here, F316 is this one, 3 is this one, 16 is this one. So that is at what was the level of significance that was specified? Nothing. So then 0.05 we are going to take. So that is 3.24. Okay. So then this value is 3.24. So if we had to test the hypothesis that each of these 4 ranked schools are equal, they are not, they are equally better, would you reject or would you not reject the null hypothesis? What would be your decision?
So the F statistic is less than the value we got. So we will reject the.
We are going to reject H naught. Yes. And what would have been that H naught? That is mu1 equal to mu2 equal to mu3 equal to mu4. Okay. I hope this is clear. Then we'll proceed to the next one. Okay. So suppose you have been given an incomplete table like this. How are you going to fill it up? Only this information is given. There are 7 treatment groups with a total degree of freedom of 36. So 7 treatment groups. So K here is 7. Total degrees of freedom is 38. So n will be, so n minus 1 is 38. So then n is 39. Okay. So here what we are going to put, also we know SST equal to SSB plus SS within. So SSB is also sometimes known as the treatment, okay, and SS within will contribute towards the error. Between will contribute towards the treatment, within will contribute towards error. So then treatment will be 84 minus 66 would be how much? 18. Okay. Degrees of freedom will be K minus 1, that is 6, and the other it will be subtracted, or n minus k. It would be 39 minus 7, that is 32. So these are all adding up to 38. Mean square will be 18 by 6, that is 3. This will be 66 by 32. How much will it be? Sixty-six by 32. How much is it? Sorry, can you be a little louder?
2.06.
2.06. Okay, this is 2.06. So then the f value will be 3 by 2.06. How much width is it coming to?
1.46.
1.46. Now, what is the decision of the analysis if we choose alpha to be 10%? So, what we are looking at is f 6, 32, 10%, that is 0.1. So, if we have to go to the table f critical, then what were the degrees of freedom? It was 6 and 32, right? So, 6, 32, yeah, we have to find out exactly what it is. There are softwares which can help. One second. Okay, this will be QF 0.1. The numerator degrees of freedom was 6, denominator was 32, right?
Yes.
So it is 1.96, the figure. So here F critical, this is 1.96. So what we have is less than 1.96. So what is the decision?
So we will accept the H naught.
We do not reject. Please make it a habit of saying do not reject, because we are not exactly accepting the null. We don't have enough evidence to reject null. Okay. So this is the interpretation, and try to make use of that. We say in colloquial terms that we accept H naught, but essentially what we are doing it, we do not have enough evidence to reject our null hypothesis. So we will write that we do not reject null hypothesis and infer that the treatments are equally effective. Okay, I hope this is fine. So another variant of a same kind of a sum is this one. Sorry, this one. So here, if you study the problem carefully, can you tell me how many groups are there?
Four groups.
Yeah. So K will be 4. Okay. What is the variable that we are trying to consider?
It is anesthesia.
Yeah, length of stay of anesthesia. So
Oh,
yi is this column. This column actually we are trying to consider. Okay. So then if I have to find out group A yi naught bar, how will I take it out? It will be 3 into, sorry, so there are 6 patients with 3 minutes, let's say, or 3 hours of length of stay of anesthesia. So then 6 into 3 plus 14 into 4 divided by, how many total patients are there? 20. Okay. Similarly, y2 naught bar will be 18 into 4 plus 2 into 5 divided by 20. y3 naught bar will be 10 into 4 plus 9 into 5 plus 1 into 6 divided by 20. And y4 naught bar will be 4 into 8. So essentially this is the frequency column, okay, and this is my y response column, yij. 8 into 4 plus 12 into 5 divided by 20. So we have all our group means like this. Then SS total, sorry, the grand mean, group mean will be y1 naught bar into 20 plus y2 naught bar into 20 plus y3 naught bar into 20 plus y4 naught bar into 20 divided by 80. Do you agree with me?
could you please
Yes.
explain once again, like the why
Okay.
not?
Okay. So if I here they are saying there are 6 patients with 3 lengths of stay. If I, this is a summarized form in which they have given the results. If I do write it like this, 3 3 3 3 3 3, then 4 4 4 4 14 times. Okay. So then the
Oh,
group means will be, we are adding 3, all 6 threes, all 14 fours, and then dividing by the total number, that is 20. That's what I have done. Okay. This is clear?
yes, yes,
Okay. Now imagine y naught naught bar is what? Sum of all observations divided by the total number of observations. Okay. So y1 naught bar is into 20. If we put it this side, it will give us the total stay for group A. It will give, if I do not divide, if I add everything and divide by 20, I am going to get the group mean. If I do not divide by 20, I am going to get the group total.
yes,
So the group mean into the total number of observation is giving me group A total. So this term is actually giving me A total. Okay. This term is
yes.
going to give me B total. This is going to give me C total. This is going to give me D total. So once I have all the totals, how many, summing up on all the number of individuals, how many do we have? We have 20 here, 20 here, 20 here, 20 here. So we have 80 observations in total.
Yes, ma'am.
So y naught naught bar will be all of this
Yeah.
divided by 80. Is it
Yeah.
clear how we are
Yes, ma'am.
getting it? Okay.
Yes, thank you.
So once this is clear, if if we have to get So now we know how to calculate the means. How will we calculate the sum of squares between and sum of squares within? So SSB was what? Summation ni yi naught minus y naught naught bar whole square. So these figures we already have, and here ni is n1 is also 20, n2 is also 20, n3 is also 20, n4 is also 20. So if we take 20 common, then what we are going to get is summation y1 naught bar yi naught bar y naught naught bar whole square. That is 20 into y1 naught bar minus y naught naught bar whole square plus y2 naught bar minus y naught naught bar whole square plus y3 naught bar minus y naught naught bar whole square plus y4 naught bar minus y naught naught bar whole square. Is it clear how we are getting SSB?
Yes.
Okay. So similarly, if we have to get SSW, what do we need? We need summation yij minus yi naught bar whole square. Right? So for this one, we are going to do the same thing. So yij minus this one will be, so if I break it up, okay, here we have 3 3 3 3 3 3 6 threes. So 6 into 3 minus whatever is the group way y1 naught bar whole square plus 14 into 4 minus y1 naught bar whole square. Then again plus 18 into 4 minus y2 naught bar whole square plus 2 into 5 minus y2 naught bar whole square, and so on. You got the logic? So if I break it down, then it will have 3 minus y1 naught bar whole square plus 3 minus y1 naught bar whole square plus 3 minus y1 naught whole square. This will go on 6 times. Then we would have 4 minus y1 naught whole square, and that would go on 14 times. So we are just combining that in this sentence, in this form. Okay, I hope this is clear to you.
Yes.
Okay, so this is how you calculate the SSW and SSB. You already have n is 80 and k is 4. So if we have SSB, if we have SSW, we have n, k, and we also have the F cutoff. So if I have to find the ANOVA table, I'll just write the ANOVA table here. So the sources will be anesthesia type and error, and this is total. So sum of squares we have SSB, SSW, SS total, we'll add them and get SS total. DF, this will be k minus 1, so here it will be 3. This will be n minus k, that is 80 minus 4, 76. This will be MS, the MS values SSB by 3, SSW by 76, and F would be MSB by MSW, and the F critical point would be F376 0.01. Is it okay?
Yes, yes, understood.
Okay. So these were a few examples of the one-way ANOVA that we have discussed in class. So apart from that, we also discussed something related to two-way ANOVA, where we can test for either independent effects or combined, or which were called as interactive effects. Okay. So how do we conduct a two-way ANOVA? First we have to see that there are two factors which are on which the dependent variable depends on, and there could be several levels of each of these A and B factors. So if we have to find out how different from each other are the means for levels of variable A or variable B separately, then we will test for main effects. And if we are to find out how different they are together, then we have to test for interaction effects. Okay. So and how are we going to do this? So in ANOVA, what we are doing, we are factoring the total anybody is here? Any
Uh,
questions? Yeah,
no,
say.
actually, so in the two-way ANOVA, like the example you gave for one-way ANOVA, that the color wrapping color will be different. So for that, if we add like the weight of the packet, so it will be two-way ANOVA.
That will become ANCOVA because weight is not a factor with levels. That is a continuous variable.
Okay.
Okay, so that design will fall under ANCOVA.
So what could be the example like for
For
two-way ANOVA?
two-way ANOVA, like I said, if you say wrapping paper is one, then apart from wrapping paper color, it could also depend on if we say that how heavy is it, if we categorize the heaviness of that parcel,
Okay.
light, medium, light, moderate, or very heavy. So
Okay.
then these are factor variables with 3 levels. Then that becomes a factorial design, or a two-way ANOVA approach, where we are trying to find out if these two, if weight and the color are together influencing the sales of a package or not.
Okay, ma'am. Thank
Okay,
you.
so just remember, in ANOVA we are primarily dealing with qualitative or categorical variables. When we are adding something, when we are mixing the two up, like qualitative and categorical, that time we are actually doing an ANCOVA model. Is it okay? I
Yes,
hope
ma'am.
it's clearer now. Okay. So what we would do in ANOVA approach, we would divide it into variation between groups and variation within groups. We would take it as error. Now this one, previously we had one, when we had one effect, one this thing, so this part can be further divided into variation from factor A, variation from factor B, and variation from factor AB. This is nothing but the interactive, jointly how factor A and factor B is influencing my response. So if we come to the model, this is how the ANOVA model looks like, a two-way ANOVA. In these table, this is how a ANOVA, two-way ANOVA table will look like. Okay, so here we have the columns, sources of variation. It could be A, sorry, okay, just remember this table. So it could be factor A, factor B, their interactive effects, or within, which is nothing but the error, the total. This is the sum of squares, and degrees of freedom will be for testing main effects would be if A has, so let us say this factor A has A levels, factor B has B levels. So then their corresponding degrees of freedom will be A minus 1, B minus 1. For interaction it will be a it will be a product of A minus 1 and B minus 1, and for within it will be AB n minus 1, AB into n minus 1. And here we have AB n minus 1. Okay, so from here it is implicitly assumed that n is the number of observations in each AB cell. So what I am trying to say is that here let us say we have factor A with A levels 1, 2, A, factor B 1, 2, B. In each of these cells, if we have n observations here, n observations here, then total number of observations will be number of boxes. There are AB boxes, and each A box has n observations. So then that will become my capital N, and the degrees of freedom will be capital N minus 1. Okay. So this column is a simplified, this table is a simplified case where it is assumed that each AB combination cell has equal number of observations. Otherwise we have to modify accordingly. Okay, so just keep this in mind. Alright, so how are we going to test for the two-way ANOVA? So for the similarly as we did for one-way ANOVA, we will construct a two-way ANOVA table. We will consider this MSA by MS within and MSB by MS within as a test for main effects, and this interaction term MSE by MS within, that this we are going to use for our interaction analysis. So here if we are testing for difference between levels of factors A or levels of factors B, then this will be my f observed, and the degree of freedom will be f of A minus 1 into n minus AB, whatever is coming from here, okay, within ABN minus 1. Okay, and no, not ABN minus 1, this one was AB into n minus 1. Okay, so whatever the degree of freedom is for, so this one was AB into n minus 1. So they are doing ABN minus AB, where this n is the total n. Okay, this is ABN minus AB, and ABN is nothing but the total number of observations. Just bear this in mind. Okay, for MSB also, this n refers to the total number of observations. And to test for interaction levels, we are going to find out f a minus 1 b minus 1 and n minus ab. Is it okay? So with that we'll solve one of the questions. Just a second.
So ma'am, here we have to compare like each critical value from like within A and B and then between A B.
Yeah, so depending on the hypothesis, if the hypothesis is that is your levels for factor A equal, then you have to test for main effects. If they are saying like if the question is such that it looks like it is wanting some sort of interaction effect, then we have to see. Okay. So here table, so if we consider this problem, table 2 gives the output levels of a farm which used 4 different types of fertilizers and 3 different types of pesticides. So fertilizer is one factor, factor A, with 4 levels. Pesticide is the second factor, factor B, with 3 levels. Do you think at 1% level of significance means of output for different fertilizers are identical? Okay. So here they are asking if only about fertilizers. So let's say mu A is about fertilizers. Okay. So they are trying to find out mu A, if mu A1, mu A2, mu A3 equal to mu A4. A is my fertilizer. Okay. This is the hypothesis that they are going to test. So for this one, we have to find out the ANOVA table. Okay. ANOVA table, it's going to have, so we are assuming that there is no interactive effect between this fertilizer and pesticides. So we will keep it simple. So sources of variation will be A, B, error and total. Okay. And we will have DFs, SS, MS, F. Okay. So now how are we going to find out? Alright. So for total SST, this is nothing but double summation Yij minus Y naught naught bar whole square. Okay. So Y naught naught bar, how I am going to calculate 21 plus 13 plus 8 plus 12 plus 10 plus 8 plus 9 plus 8 plus 7 plus 6 plus 5 plus 1 divided by 12. How much do you get it?
Uh, 12. 12.
This is 12. No. Why not bar? That is the grand mean.
No, it's 9.
It is 9.
9.
Okay. So the grand mean is 9. So we'll do one thing, we'll just for ease of understanding, we are going to draw one small table. Okay, so here we have these. So the grand mean is 9. We'll calculate each of the group means now. So for here, let's say fertilizers, for fertilizer 1 is what is the group mean? Let's say this is factor I, this is factor j. So xi bar will be this one. So 21 plus 13 plus 18 divided by 8 will be how much? x1 bar is 21 plus 13 plus 8 by 3 is 21, 21, 42 by 3. This is 14. Is it fine? Similarly, this will be 22 plus 30 by 10, 10, 15 plus 7, 24 by 8, and this will be 6, 6, 12 by 3, that is 4. Similarly, xj bar would be row sums, row means. So how much would you get? This one would come as 12, this would be 9, and this would be 6. Okay. So now SS total will be double summation yij minus y naught naught bar whole square. So it will be 21 minus 9 whole square plus 13 minus 9 whole square plus 8 minus 9 whole square plus 12 minus 9 whole square, and so on and so forth. So this would come out as this would come out to be something around 266. You can check. Okay. Now SSA, A is my columns. Okay, factor A is columns. So SSA will be, we are going to find out how much these column means are deviating from the grand mean. Okay. So what we are going to do? We are going to do it as, you remember we were multiplying it by n. So how many observations are there here? So we have 3. So we will have 3 into 14 minus 9 whole square plus 3 into 10 minus 9 whole square plus 3 into 8 minus 9 whole square plus 3 into 4 minus 9 whole square. This will be my SSA. SSB, when we are doing, then the rows are my categories. Okay. So then SSB would be these row means minus, so then SSB would be n into, so how many are there in each row? 4. So then 4 into 12 minus 9 whole square plus 4 into 9 minus 9 whole square plus 4 into 6 minus 9 whole square. This would come out as 72 and this would be something around 156. So, once we have SST, SSA, SSB, we will also have SSE, that is SST minus SSA minus SSB. Is it okay? So, the crucial thing is when we are trying to find out the differential effect for factor A, then we will forget about the this thing. We will just consider these as factors. So, then how would we get between group things? We would take the group means, multiply it with the number of observations in that group, and then we take the group mean, we subtract it from the grand mean and multiply it with the number of observations pertaining to that group only. So, by similar logic we will get SSA and SSB. So, once we have SSA and SSB, so here we have SS. So, if I have to construct the ANOVA table, we have SSA, SSB, SSE. So, SSA was fertilizer, SSB was pesticide, SSE was error, and this is SST. So, this one we got it to be something around 156. This one was 72. This one was 266. So, if we subtract these, we add this and subtract it from here, we will get it to be something around 38. Now, the next thing is degrees of freedom. So, when we are considering fertilizers, we have how many levels? We have 4 levels. So, then it will be 4 minus 1, that is 3. When we are considering pesticides, we have 3 levels. So, here we have 3 minus 1, that is 2. Then here SST, what we will have? N minus 1. So, how are we going to calculate N? So, here we see for each of the IJ blocks, we have one observation, right? So, then total number of observation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, we have only 12 observations. So, N is 12, then this will be N minus 1 will be 11, the degrees of freedom. And then this would be 11 minus 5, this is 6. Okay. Or alternatively, this will be 4 minus 1 into 3 minus 1, A minus 1 into B minus 1, okay, same thing. So, then the mean square will be 156 by 3, 72 by 2, 38 by 6, sorry, yes, and F would be, this one how much are we getting? 156 by 3,
52.
This would be 52. This is 36 and this is something 6.33. Okay. Yeah, so MSCs are done. So, now we have to find out which F value we are going to use. So, in this question they have asked if the output of for different fertilizers are identical. So, here our hypothesis is with respect to the 4 fertilizers. So, we are going to take the F observed as MSA by MSE. So, it would be 52 divided by 6.33. How much do we get that?
8.1.
This will be 8.21. And my F critical will be F critical for this hypothesis will have a degrees of freedom of F3 6. 3 for this one SSA and error DF is 6. Numerator by denominator DF and the alpha level of significance whatever it is. So here we have, it has been given that at 1% level of significance, that is 0.01, this is given as 9.78. This is 9. So what will be our decision?
We do not reject the null hypothesis.
Exactly. So we do not reject the null hypothesis. So the ultimate answer is do not reject null and interpret what? That they produce all fertilizers give same output. Is it okay?
Yes. Actually, I have one doubt. Like
Yes.
now we are dealing with only two kind of qualitative things. So in economics, like if we see GDP, so it might have so many things like for more than two. So in
Yeah.
that case, like what will use?
In that case, we have to go for some sort of generalization. The same thing, we'll whatever we are doing, we'll apply the same concept. So the concept is sum of squares between plus sum of squares due to errors. So this thing we are going to further tease out. Okay, so from here, if we have fixed on whatever we have, here we are going to tease out and get some revised orthogonal sets, so that each of these levels correspond to some of the factors, let's say A, B, C, D, whatever you have.
Okay.
Okay, and there will be some residual error. As and when you suppose here with two factors you have this thing. Okay, with three factors you will have SST equal to SSB dash plus SSE star. So some of the unexplained variation would be pulled in by addition of a new kind of a factor or new variable. Okay, so this will go on, and the analytical forms will get complicated, but that is what happens. We are partitioning the deviation from the mean into discrete or separate orthogonal components.
Okay.
Okay, so similarly, if for this test, if you are said that compare if the pesticides are equal or not, we are going to take a decision based on MSB by MSC. So for testing that, let's say this one, means of output of pesticides are equal, we will test MSB by MSC. So that will be, here what was MSB? 36 by 6.33. Okay, it will be 36 by 6.33, it will be something around 6 point something, and the degrees of freedom will also be F2, because this one is having 3 levels. Okay, pesticides, and the MSC, the error DF remains the same. So 260.01 is 10.92. Here also we do not reject. Is it okay?
Yes.
Okay, so I think we'll stop here today, and if there are some other residual questions, we'll take it up next week. Is it okay?
Yes, ma'am. Okay.
Okay. Any other questions? Questions, comments, feedback, anything you want to say, you can share.
Uh, Actually, it is very helpful for me. Like,
Okay.
and the thing I prefer this week 5. So instead of doing after the assignment, if you do before that, so it might help me to complete the assignment and get some good grade in assignment.
Okay. Actually, this time the classes, these sessions started a week late. So that's why maybe I'll see. I'll try to incorporate whatever we have, uh, the previous week's things. Okay, I'll try to do that from the next day.
Yes, ma'am. Actually, what I feel like after seeing the lectures and when I attend your classes, it is clear to answer the assignment questions. So
Okay,
that's
okay,
what I feel.
okay, okay, okay. I'll see what I can do. I'll try to do that.
Okay, great. Thank you,
Okay,
ma'am.
thank you. Anything else? Okay, if not anything, then I'm going to stop today's session. Thank you very much for joining. And if you have queries, post it in the discussion forum, or please join the sessions and get it cleared. Thank you so much.
Thank you, ma'am.
Thank you. Bye bye.